So let me show you what we're going to do. So the first thing is, of course, we have the Grace Hopper superchip. Put that into a computer. The second thing that we're going to do is we're going to connect 8 of these together using NVLink. This is an NVLink switch. So 8 of this connect into 3 switch trays into 8 Grace Hopper pod. These 8 Grace Hopper pods, each one of the Grace Hoppers are connected to the other Grace Hopper at 900 gigabytes per second. 600 gigabytes, 900 megabytes per second, 8 of them connected together as a pod, and then we connect 32 of them together with another layer of switches. And in order to build this, 256 Grace Hopper super chips connected into 1 exaflops. 1 exaflops. You know that countries and nations have been working on exaflops computing and just recently achieved it. 256 Grace Hoppers for deep learning is 1 exaflop transformer engine, and it gives us 144 terabytes of memory that every GPU can see. This is not 144 terabytes distributed. This is 144 terabytes connected. Why don't we take a look at what it really looks like? Play, please. This is 150 miles of cables, fiber optic cables, 2,000 fans, 70,000 cubic feet per minute. It probably recycles the air in this entire room in a couple of minutes. 40,000 pounds. 4 elephants. 1 GPU. If I can get up on here, this is actual size. I wonder if this can play Crisis. Only gamers know that joke. So this is our brand new Grace Hopper AI supercomputer. It is 1 giant GPU, utterly incredible. We're building it now. Every component is in production, and we're so excited that Google Cloud, Meta, and Microsoft will be the first companies in the world to have access, and they will be doing exploratory research on the pioneering front, the boundaries of artificial intelligence with us. We will, of course, build these systems as products. And so if you would like to have an AI supercomputer, we would, of course, come and install it in your company. We also share the blueprints of this supercomputer with all of our cloud suppliers, so that our cloud partners, so that they can integrate it into their networks and into their infrastructure. And we will also build it inside our company for us to do research ourselves and do development. So this is the DGX GH200. It is 1 giant GPU. Okay?
So here's the breakdown. Number 1, it eliminates traditional CPU to GPU connections. The GH200 integrates NVIDIA's ARM-based Grace CPU and H100 Tensor Core GPU in the same package, which means this increases bandwidth between GPU and CPU by 7 times compared to latest PCIe, while reducing power consumption by over 5 times. Number 2, increased scale and speed. The DGX GH200 is the first supercomputer to use Grace Hopper superchips and the NVIDIA NVLink switch system. This allows them to work together as one, allowing simplicity of programming a single GPU. This increases 48 times more than previous generation. Number 3. Support for larger AI models. With current pace of AI model growth in both size and complexity, they require powerful infrastructure that can scale to meet these demands. This is where DGX GH200W/1 exaflop and 144 terabytes of shared memory comes in. Number 4. More efficient AI training. Training large AI models is super resource and time-consuming tasks. With the DGX GH200's ability to work with terabytes of datasets, developers can conduct research at larger scale and much faster speeds.